Hi,
Hello.
we can start, I guess, in a few minutes because people are gathering from the break. Okay.
Okay.
All right. Everyone is informed that we are starting the lecture, so I guess we can begin.
Okay, cool. I will share my screen. Can everyone see it? Is it visible? Cool. Um, Hello everyone. First of all, I want to thank you to Isaac for a nice talk yesterday. I will start with a brief introduction about myself. My name is VJ. I am Chief Technical Officer at Brooklyn Health, which is a biotech startup in mental health space. I have overall of 10 years of experience in R&D and productionizing machine learning application in healthcare domain. By training, I am an engineer, but get into the research domain mainly in CNS with Isaac and was involved in development of dozens of sensitive health markers like facial expressivity, face tremor, voice tremor, hand tremor, and many more. And eventually, these markers are direct indicator of human behavior that are helpful in advancing the precision medicine. As part of objective, I will start with a brief introduction on what exactly an agent is in technical words, and then we'll give a demo on how you can run the LLM-based agent in your local machine, which includes installation of all the necessary toolkits and frameworks we need to inference a small or a large language model in local machine. That eventually will be helpful when you guys are going to work on the project. I will also give a demo on how we can launch them on cloud like AWS and present a real-time health case or health use case scenario. Um, okay. So in simple words, an agent is an AI assistant that is designed to perform self-determined task to perform a predetermined task. Humans, which means humans is initially supposed to set up a goal for an agent. They assign the role to that particular AI agent, and then the agent is going to choose the best action it needs to perform to achieve the final goal. And in between the process, you can set up human intervention in case you want. Otherwise, the chat is going to communicate with the user agent, which represents the human, and continuously going to generate the response based on the final goal. The key feature of LLM agent is autonomy. It operates, it can operate with or without human intervention, but in general, it operates without human intervention. An example, let's say I have a multi-agent um, scenario where I have three agent. First one is user agent that represents the human, and other two agents are my AI assistant. So first one is let's say planner, and the second one is developer. And as a as a goal to the user agent, I set up a goal that I want an agent to write the Python code for me, let's say to reverse a string, or maybe to generate the web application and share me the code of everything in my local machine. So the user is going to give the command to the planner. Planner is going to write up all the planning that may involve behind it and accordingly guide the developer agent to write the codes according to that planning. And then planner and this developer agents are going to communicate with each other until it come up with the final executable code, and then eventually it is going to save the code in my local machine. So these are like very basic or general use cases where people use it in real time for other applications, or maybe to write their own code or do their assignment or whatever. Reactivity, it respond in real time. Proactive, sometimes it anticipate future events and take proactive measures specific to that. Social ability, some AI agents are designed to interact with other agents, including both humans and other AI system like robot or self-driving car. And it also comes in the same category, the example which I gave in case of autonomy. Specific application in healthcare, which where these agents are actually deployed is appointment scheduling, medical information retrieval, or sometimes clinical decision making. In general, if you go on internet, you will find X number of or X type of agents, but mostly they are categorized under four categories. First one is conversational agents. These agents are designed for the interaction between the human and AI assistant using natural language. It can be any language, depend what's the model behind it, or in which language that model is trained. They can be used in chatbots, customer support services, or virtual agents. Next is task-oriented agent. These agents are designed to perform specific tasks such as booking appointment or sending emails. And these processes can be multitask process. I mean, in between there can be 3 to 4 layers, and these agents are going to communicate with each other based on the response they will get at each step or stage. Next is autonomous agents. These agents are capable of operating independently without any human supervision, and these can be used in robots or self-driving cars. Last is multimodal agents. These agents can process and generate different type of data such as text, image, and audio. So whether it's a I mean, like whatever kind of data you want to feed to these agents, they will come up with the response to it, like text to speech, speech to text, or speech text to image, or whatever. Hmm. Next is classes of agent. So again, it's like you can have multiple classes, but in general, you have like two, which is single agents and multi-agents. Single agent is something which I guess everyone has interacted as of now. ChatGPT or Bard is one of the example. So it has like multiple categories inside it. That depends how you are building your bots. So first one is conversable agents, which is a simple chatbot where take an example of ChatGPT, user writes some instruction and the bot will respond accordingly based on the input. Second one is instructional single agents where you have a single agent and you define the role of user and system, which is the agent inside your script, and then it is going to iteratively communicate with the bot itself. You don't need to feed any user input. You already predefined the role of that agent. In conversable agents, you can set up the system response, but user is free to write whatever they want. Second is multi-agents. In this case, again, the same example which I gave previously. More than two AI assistants, more than one AI assistant is involved in the process, and they can communicate with each other to come up with the final response. I guess this is where you guys need to follow up that how we can run or create the agents in local machine. When it comes to hardware, I guess whatever devices or machines, be it Windows or Mac, will work for it. And for installation, you need to install LM Studio. I'm going to show that. Uh, I can take you to there. So go to lmstudio.ai, and they have listed all the available snapshots or binary images specific to each machine. And according whatever system configurations you have, you can download the snapshot from there and install it in your local machine. So LM Studio is a desktop application to run LLMs in your local or inference LLMs in your local machine. Um, I will go deeper into it, that what are the functionalities or how you can use it. When it comes to Python, I guess you can use even 3.9, but recommendation is it's better to have either 3.10 or a greater version. In terms of dependencies, for the example which I have prepared, I'm using OpenAI and PyAutogen, which is AutoGen library developed by Microsoft. So these are the like general libraries which people use to invoke or inference the large language or small language model, generally in local machines or on cloud platforms even. Before getting into the demo, I just want to talk over the some popular frameworks as well. Like every day something new is coming up. And if I talk about like most popular frameworks, then it's Llama Index, LangChain, DSPy, Crew AI, AutoGen, and more. Even LangChain yesterday come up with an IDE for creating the, not yesterday, I mean like few weeks back, come up with an IDE to create the agents in local machine, just like LM Studio. So every day things are coming up, but it like when it comes to like which library or framework you should choose, it totally depends on the use case you are working with. So in Llama Index, if it's a data framework, I mean, it's a data framework specifically designed to build LM-powered application focusing on efficient data indexing and retrieval, where if you are building an application where you are fetching a data from, let's say, X number of resources, be it your database, from documents, PDFs in your storage, or maybe data available on your computing storage like S3 on AWS or GCP or wherever. So if you have like those multiple data storages and you are doing some retrieval or search based operation, then Llama Index is more popular to use. For LangChain, it is most commonly used for framework, most commonly used framework for developing general purpose application powered by single or multiple LLM models. It has its downside in terms of memory utilization, but most commonly used by like the people or researcher around. DSPy, it is a tool for debugging LLM application, but they also come up with like functions or modules that you can use to create the agents. Through AI, it focuses at creating multi-agent system that collaborates on tasks and automate workflows. I mean, if you want to automate your operations, that's where mostly it is used. Plus, they have some inbuilt module that are really good in curating the data or making, or if you want to fetch something from internet, that those modules are pretty fast. Autogen, which I am using for my demos, it simplifies the creation of conversational agent with its focus on prompt engineering and dialogue management. So each library has its plus and minus. It totally depends on the use case or your project which you are working on. Another thing is the medium or the platform or a library which we are using to basically inference our LLMs. There also you have multiple options. Few of the commons are LM Studio, and the second one is Olama. So Olama is a Python library that is easier to use in case we want to perform specific task on a specific model. You don't need to install any binary or any kind of executable file. It's just pip install Olama, and you need to specify the specific model which you want to work with, and it will automatically going to inference that model for you once you invoke the Olama library. In case of LM Studio, it's a desktop application that has a user-friendly interface and has more functionality compared to Olama. So with LM Studio, you can do many things, which I will explain now. So I have already I guess I have to share my whole screen. One second. Yeah, I have already installed LM Studio in my machine. So this is how it will look once you install it. This is a home or a dashboard screen where you can see a search panel where you can search any model you want from Hugging Face. So it directly connected with the Hugging Face. Any open source model which is available on Hugging Face, you can directly import or invoke here. On the dashboard or home screen, they have some most commonly used model, both small and large language model, which you can directly download in your local machine. They also specify what system configuration that particular model requires. So according to your system configuration, you can pick up which model you want to work with. Simply click on download. You will see, I will show you one small example, maybe with Gemma too. So you will see the panel here when the download is in progress. And once the download is done, you will see all the models which are downloaded here. So in my case, I already downloaded 5 3.1 and Mistral 7B. And again, it totally depends on the use case, which model you need to pick. So in my case, I am going to give a demo on convertible agents. So Instruct LLMs are like most commonly used for convertible agents. In a way, they are trained in a way that they work better in terms whenever someone is doing a conversation with the model. So you have to do some kind of review or research on internet that which model is trained for what specific purpose, and accordingly you can pick up that model. So it may take a couple of seconds until we can look for other things. This is the search tab. Again, you can type, let's say Mistral. It will pop up all the possible models which are available on Hugging Face. Now, if you see here, these models are not the foundational model, which is maybe uploaded by Mistral or Meta or Google. So people actually fine-tuned on these models, like take an example of multilingual language. So maybe somebody trained a model on multiple languages so that the model can do transcription or maybe translation across multiple languages. So for those specific tasks, also you need to maybe go directly on Hugging Face, and people already have described like for what purpose they have trained or fine-tuned those models. And accordingly, you can directly pick up those fine-tuned weights. When it comes to fine-tuning, then they pick up the base foundational model, and then they had their own data, maybe specific to one domain, let's say mental health, and then they fine-tune that the weights of those foundational model that will learn the content specific to mental health. And that's how basically mostly people use it. But commonly, fine-tuning is done in case you have very large amount of data. Otherwise, most commonly used approach is RAG, where you have some dynamic content specific to your domain, and you make a call to foundational model and provide that dynamic content to the model in the context, and based on that, the model is going to generate the final response. So the download is done. You can see it is listed here. You have an option to see all the configurations and delete the model in case you want to clear memory. Next is AI assistant or a playground, a chatbot playground. So another good use case of LM Studio is in case someone is working with PHI data or PI data and then using Bard or ChatGPT, then you are exposing your data to OpenAI or Google. So for those scenarios, you have an option to, instead of using these online toolkits, use LM Studio, select the model which you want to use, And then you can have a same conversation with the model, and you can ask those specific question what you are going to ask in ChatGPT or Bard. So let's say, so it's going to respond in the same way, and will save the chats accordingly. And it's your option, you want to keep them or delete them. And you can also set up certain configurations for that specific model, like system prompt, that if in case you want that model to respond or behave as a researcher, then you can set up all those predefined prompts. You also have an option to modify some advanced configuration like context length. That totally depends on the maximum token which you can input to the model. So context length is basically the input which I am giving to the model. So in case of Phi-3, it's 4096 token, which is somewhere around 2100 or 2200 words. So in one go, you cannot send more than 2200 or 4096 token to the model. Otherwise, it will not work. Recently, there are like many models like Mistral 7B and Gemma 2. Like they have a very large context window, maybe of 32K or more. So in that scenario, you can pass 1500 to 15,000 to 16,000 words as an input to the model, and the model is going to respond accordingly. You can set up the GPU configuration in case you are working on a GPU machine. You can also set up some, where is that? Yeah. You can also save some presets for your chat, as in like in future, if you want to come back and look for like whether that chat response was reasonable or correct or not. So you have option to basically set up all those parameters in here. Next is Playground. So it also has a functionality where you can compare the how multiple models are working for a same problem. So in a way, right now it automatically has uploaded Phi-3 because I uploaded that model. Now let's say I have a problem and I want to see which model is working best for that. So let's say I'm uploading Mistral 7B instruct as well. And then I'm going to pass a prompt, and the both model are going to generate the response for that. And you also have an option to set up configurations again for both models, maybe GPU or CPU utilization parameters in case you want. So this is again system prompt in case you want the each model to behave in a specific way. So this is where you need to send your response. So in here you can see this result is generated by Phi-3, and the green one is generated by Mistral. And then you have an option to basically see which model is performing best according to the expected response. And that way you can label the best model according to your requirement. So this is it. Now, once you're done, eject these model because they take some portion of your memory. If you have a low configuration, then it's mandatory to eject them. Um, Next is how you can inference these model into your local machines, and eventually how you can basically create predefined prompts where you can set up some role or for system and for both UI agent, and that way how it's going to work for or do those specific operations. So this is local server where you have an option to load and host whatever model you want according to your system configuration. So in this case, I'm going with a small model, which is Phi-3, and it will automatically start the server. So in here, now it's ready. Again, you have all those configurations option, which I have explained before, but let's say everything is default, and I am going to run it now in my local machine. So I have these examples are just to create the Python script. I did not create any example specific to use healthcare use case, but you have option to basically convert them into any application you want. Um, for this, first example is specific to conversable chats or chatbots. For that, I am using OpenAI library. So usually, if you want to invoke the OpenAI APIs, which are paid APIs, you need to pass the base URL of that API and the API key associated to that. Because it's paid, so I'm not giving that example. And in case like this is specific to hosting a model in your local machine, so you need to pass the base URL, which is your local host where the model is hosted, and this is going to be default for whatever or any kind of model you're hosting. API key in this situation, we don't have any API key because the model is already hosted in local, so you can pass whatever XYZ content here and automatically it is going to pick up the hosted model. Doesn't matter you have hosted Phi 3 or Mistral, whatever, and you pass that name. It can be XYZ or whatever, but it is always going to pick up the model which you have hosted. So in here, I'm making a call to my inference endpoint. So LM Studio will basically host these model weights as an inference point on this local host. And with that, I'm making a call to chatbots function, which is chat. That is where I am defining the role for system and my user. Now, there is no human intervention in between, and it will work as an agent on its own, going to communicate with the user agent is going to communicate with the AI assistant and will give me the response. Temperature is basically it's a variable to control the randomness in the response generated by the AI assistant. So you have to tune it according to the use case which you are working on. So in this particular scenario, I have set a role for user as introduce yourself. So the user is going to ask the AI assistant to introduce yourself. And then I'm defining a specific behavior for my AI assistant to work in that specific way. So it is going to return me a single response only. It's not a iterative chatbot. I have just specified one role, and accordingly, it's going to return me that specific answer to that specific role. So this is the response which is returned by the end of the day by the LLM model. But this is like the structure how you can create a simple chat-based agent. Second example is where you can have iterative conversation with the bot. So nothing different. Everything is almost same. I just add a while loop in there and define the role for for an AI assistant as that like you are a research assistant, and again user is like introduce yourself or whatever role you want to pick there. It's totally the use case and user's choice. So in the first iteration, it's going to pick up this message and the AI assistant is going to return the response specific to this message. Now I have control as a user. So there is a human intervention in between and it will work exactly same way the any other chatbot works. And you can ask any question you want. So this is like chat agent based example, which are mostly single agents. Next is multi-agents, where the first example is conversable agents. Now I have, instead of setting up a role, I am using two agents. One agent is for my user, and the second agent can be my AI assistant, conversable agent, RAG agent, or whatever kind of agent you want to use. All these functions are already available in the in the package. And you can go in here in AutoGen and pick up the whatever choice of agent you want to use. So this retrieve user agent, if you, in case you want to do RAG, if you want to implement a RAG-based application in your local machine, you can use retrieve user proxy agent instead of user agent. So in here, um, everything is again same in terms of invoking the model. Again, you have an option to pass these additional parameters in case you want, otherwise it will pick up the defaults. For first thing is we have to define the user agent, where we have to define what operations user can do. And in there, like you have option again to set up certain configurations you want. So for user agent, I have defined a role name as user proxy and a default auto reply of, let's say, dot dot dot, and human input mode is never. So in general, you have three options for human input mode. Always is, it will become sort of an agent which always require human intervention. So after each iteration, whenever the model is going to return the response, it is going to ask the user, do you want to continue? If yes, what prompt you want to send to the agent? Never, it's never going to ask. Terminate once all the maximum iterations are done, which in case we define, then it's going to terminate the conversation between both agents. In this situation, I'm using a conversable agent where I define the name, let's say Sam, and set up the system message that so that it should behave in that certain way. And then eventually initiate the conversation of user and the conversable agent, which is Sam. Iteratively, it's going to communicate between both user and the conversable agent, which is Sam, because I did not specify any max limit. So they are going to continuously communicate to each other. Maybe in a certain way or specific message. For user, I have set up, let's say, dot dot dot. So every time it's going to send that message to my conversable agent, and this conversable agent is going to randomly generate some text or whatever you are expecting as a response. And you have an option to change the default auto reply in case you want. So accordingly, the AI assistant is going to return the response. So in this case, I have to kill it because it's running like iteratively without any maximum count. This one is, I mean, it's confusing. I name it as single agent. Um, Technically, user agent represents the human. So it's not exactly an agent. It's just a function which is created to represent the human inputs. So end of the day, I'm using a single agent here. But you have an option to create multiple agents, maybe let's say planner or something, and the same way define the role for planner, and it's going to work that way. So you have an option to add as many agents as you want, and instead of initiate chat, you can have a group chat, and that way it's going to communicate with each other. So for this particular example, I have like defined the same configurations again to invoke the inference model from LM Studio. Here I'm creating a user agent where I had defined a work directory, let's say coding 01, where I want to save my code. Human input never. I don't want to basically give input to the agent every time. And a default reply is terminate if everything is done. And for that, I have defined the maximum consecutive auto reply, which is 5. So there's these agents, this user and AI assistant is going to talk with each other for 5 times, and will try to fix the code in between if there is something missing in there, execute the code. Once everything is done, it is going to create a directory with coding_01 in my local machine and will save that particular mode. So for this AI assistant, I have defined a system message or role as that you are a 10x Python engineer, write a code in Python, blah, 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 blah. And also defined instruction, let's say, make sure the file name should be this. And the first line after the tick marks, define the file name in there. And then I am initiating a chat between the user and the developer. And the message here by the user is I want you to, additional message by the user is I want you to create two different Python methods for me in a single file. One is to generate a random number, other is to basically reverse that number. So client, which is my user, is initially going to pass the message to developer, and developer will come up with, let's say, response. So this response will not considered as part of this maximum auto replies. After that, whenever they are going to communicate, from there it starts the maximum auto reply. So let's say it come up with this. If everything is done, then terminate. Developer is going to look into the code and trying to execute the Python program. If there is anything wrong, then again the developer is going to look into the code and will try to do certain things. So it will take a little time to respond. What happened? One second, let me clear the cache. Yeah. Sometimes model returns something which is unexpected, and it's totally possible that maybe the response is not reliable. So you have to add those checks in your system when you are automating everything, that if some weird response is coming, you are supposed to halt the process. So in this case, if you see here, it tries to execute the code, and if there is an error, then it's fine. It's going to return back to the agent, and the agent is going to look into it, will give you an explanation where or what is missing, and accordingly it's going to work again. Because I have set the maximum auto reply as 5, so in any situation it's going to communicate, the client is going to communicate with the developer for 5 times. And every time from client, the response is going to be this when everything is done. But you can have a dynamic response accordingly for each attempt in case you want. So for that, you just have to maybe come up with those auto response in a list and then iteratively pass in here. So all those options are available. So if you, it will take some time. If you see here, did it generate? I guess it will generate once the execution is done. So it created this directory. Once execution is done, it should save the file. Mm. Again, it's executing on local machine, so it takes time. And in here, you can see like it's working in the background. So it's generating the response, and you can see all the response in the server logs in here. So right now the CPU utilization was like 6, it's currently 50, it was 60 before. So again, it depends on the system configurations you are using. So you see here, it has prepared the response. It should, yeah, it moved forward. How many conversations? One, two, three. Oh yeah, it will execute two more, I guess, and then it will be done. And you have also have an option to set the response limit. So right now I'm using default configurations. So that's why it's going to generate the continuous response, which I cannot control. but you always have an option to set a limit. Maybe the explanation should be in 100 words or something, and accordingly it's going to work. Let's wait for a few more minutes if it's done. Till the time you can go and see the examples here in case you want to refer them, and all the instructions are written here, like from where or how you are supposed or which library you need to run these examples. Okay, this is done. Oh, I didn't create that code. Why? Not sure why it's not creating the code. It was creating 30 minutes before. Again, I had to clear the cache. This is manual process because I did not set up any automated pipeline behind it. I'll let it running. Once it's done, I will come back again and we'll see. But I ran it 30 minutes before the class. It was working fine, so it should work. Um, any questions? And then we'll move to the next section, which is how to create agent using cloud platforms. Okay.
Yeah, actually, I have one question. It's more about training LLMs. You know that it takes quite a lot of time, and we understand it, but just interesting, maybe you can give some tips. How can we speed up that? How can we parallelize it better? Maybe you can use some distributed learning approaches or multi-GPU approaches and so on. Just interesting, how can we parallelize training of LLMs or fine-tuning of LLMs?
Okay. So when it comes to training of LLMs, it should be, I guess, out of scope for everyone, because it will cost you millions of dollars to train these models from scratch. Um, the most popular approach after used is either fine-tuning or maybe RAG or prompt engineering. When it comes to fine-tuning, that also require you GPU machines or maybe some high computational machines. We fine-tuned some in-house model, and for that we had to use like large machine as I guess 12x large machine, which is somewhere around 8 GPU cores and I guess 32 CPU cores, which cost you around, I guess, $4 or $5, something like that per hour, or $7 per hour. So when it comes to like fine tuning, it totally depends again on the use case. If you have very small amount of data, then it doesn't make sense to fine tune a model because already with the RAG approaches, all these model come up with the bigger context window size, which is from 32K to 128K or something. So that means you can fit in 15,000 to 16,000 words, yes, in your context window, and then you can have a maybe very bigger storage where your all dynamic information is available. And then after fetching it from there, it is going to generate those specific examples and contexts on its own when we input the model that specific prompt. But again, when it comes to fine tuning, if someone is interested, then multiple approaches. Maybe you can start with small language models, which are lesser in parameter size, and use techniques like maybe ensembling or MOE, which is mixture of experts. That means you train small language models on a specific operation. Let's take an example of language translation. I want to train a model which can translate English to Ukrainian or opposite, and maybe English to French or English to Hindi, whatever. You train three models separately, and then you can combine them together. So that way your fine tuning will cost you less because you are training the smaller model. But end of the day, you are like getting the same information which a large language model is going to give you when you combine all those weights together. Then it's totally up to you. You want to increase the parameter size in total the way you combine it, or you can leave it on agents to go to the specific model and make a decision from where it should return the response. So there are like multiple ensembling or MOE techniques which you can follow. When it comes to hosting such large models, again, you have multiple options, because hosting is also going to cost you big money. Um, Quantization, if you heard about this term, is most commonly used where, let's say, if the model weight is 7 billion and the size is, let's say, 14 gigs of weights. If you host such model, it requires 4x, maybe 4 to 8 CPU cores to work efficiently. But if you quantize them, that means you are reducing the model size. For that, you need less memory space, and that you can run on maybe single GPU machine, and even you can run it on CPU machines or Google Colabs. But for on CPU, it's going to take more time. But on single GPU, I experimented one of the model which we trained in house, and it takes like 5 seconds to process 30-minute long speech file to transcribe it into other language or to do the speaker diarization. So after quantization, it's very fast, and you can basically run or inference it on a smaller machine.
Okay, thank you.
I will quickly check, did it generate or not? Yeah. If you see here, it generated this file, random number, and this is reverse of that number. So yeah, so you have to add all those checks in the pipeline when you basically run an agent that it is generating the expected response or not. And we cannot control it because, I mean, you can control it, but right now I'm not controlling anything, and the model sometimes can return scrap values or response. Okay, any other question? All right, I'll move to next section, which is how to create agents on cloud. Prerequisite for that is you should have, I'm giving it specific to AWS. So you should have an AWS account, which cost you. I mean, for students, some amount, I mean, they give you some free credits, I guess 100 or 300, I don't know. You can use it until you burn those credit. But hosting or inferencing large language model cost you big money. So make sure that you are, in case you access free AWS account, you are watching how many credits you are burning. Otherwise, they'll bill you. Um, Stacks which I'm using to prepare this agent is EC2 instance, IAM roles and policies, OpenSearch, which is a vector database, S3, which is a storage, DynamoDB, AWS Bedrock, and CDK. I will briefly going to give you what all these services do, just to get a basic idea or understanding behind it. But before that, I'll just show you, this is the whole code which I have used from AWS orchestration branch, that how we can host a model. So they already share, like whenever they launch a new service, they already share their orchestration branch that how you can host a specific service. So let's say for agent, I use the same orchestration branch and then eventually added my use cases and then did some minor manual and automated changes to deploy it. So first I'm going to simply talk about like these services, and then I will briefly give you an idea what is I'm doing when I'm installing or deploying this model. EC2 is AWS Elastic Compute Cloud. In GCP, it's compute instance, same in Azure as well. So in simple words, it's a virtual computer that you can rent from AWS. It's like you are having your own computer in cloud. You don't have to worry about any hardware or any auto scaling, which is upscaling or downscaling of that hardware. That is converting your CPU instance to GPU instance. You can do it all these things on the fly. For implementing or deploying this particular application, which I'm going to present, you need some prerequisites, which is NPM, that is Node Package Manager, an open source toolkit that helps developer to build application. It is a standard package for Node.js. Node, it is a runtime environment allowing you to execute JavaScript code on server side. And a Docker, it's a framework that allow you to package and run applications inside virtual machine on a server. In my case, I am using it to make a API call to other services, which I will explain later. IAM is identity and access management that controls and manages the access of user to AWS services. It has two subcategories, which is roles and policy. Now think you work in an organization where you are admin and then you have developers under you. So policies is something which tells me which services are someone can access. So I will list down all those policies. Let's say services, EC2 instance, maybe S3, CDK, blah, blah, blah. And then I role is basically which where I wrapped up all those policies under one entity. Let's say for developer, I defined one role. For admin, I defined second role. Let's say admin role. Admin is going to have access to all the policies. That means all the services. Developer may have a restricted access to specific services, which they are allowed to work on. So that way you can control the cost and resources. Next is OpenSearch. OpenSearch is again an open source search and analytics engine, which is used in use cases like log analytics, real-time application monitoring, and click-stream analysis. This is one of the, I mean, I hope you heard the term vector database, and it actually makes sense, or like most commonly discuss things over the internet in recent time, because it comes up with performance of how these models can work in both in training, fine tuning, and inference. So in our case, we are using OpenSearch as a vector database. It saves all the content, maybe your document, sentences, words, audio, image, or whatever unstructured or structured data you work with in the form of embeddings. And when we search anything, instead of finding the content from the original data source, it will look for that content in these embeddings and return the response back to the agent or model or whatever. Most commonly, these are used in RAG-based applications, assuming you have a separate storage where you saved all the content specific to whatever use case you are implementing. Instead of using that structured or unstructured data, it's going to convert that storage into a binary form, and then save those embeddings inside its storage. So whenever a user is going to make a request with a prompt, that prompt will go to OpenSearch, and OpenSearch is going to quickly, because embeddings are very small in size and very fast in searching. So it is quickly going to do the similarity check between the prompt which user sent versus the content or embeddings available in the database, and will return those embeddings back to the user. Then in between, you have embedding algorithm that is going to convert those embeddings into the natural language in case you want. But if you have a LLM model in between, then LLM model always expects embedding as input. You cannot pass the natural language directly. So in between, there are layers which converts the natural language into embeddings, and then it's feed it to the model, the way we chat with or will communicate with these models. So the same way it passed the embeddings to the model, it will generate the response. In between, there is another layer that is going to convert those embeddings into the natural language and send it back to the user. That's how we see the response in ChatGPT or other agents. Next is OpenSearch. There are like, just to add, there are like more options available as well. some sort of databases. I don't remember the name, Carger or something on AWS, something like that. There are like few databases which actually do the same thing, but end of the day, it depends on the cost. Which one is more cost efficient? You use those services in your application. Next is AWS S3. S3 is a simple storage service that allows user to save, retrieve any amount of data anywhere, anytime. There is no limit to it. DynamoDB is a serverless, fully managed, no SQL database. You can save both your structured and unstructured database in it in a binary format in case you want. Most commonly, it is used in analytical applications because querying or searching from relational database versus DynamoDB, which is a NoSQL database, is pretty fast. That's how they designed and developed it. So mostly it is used for analytical and BI specific applications. Next is Bedrock, which is like the main backbone of the stack. Um, I guess AWS launched it like a year back or something, and then they are continuously making enhancement in it to make it more efficient. So Bedrock is a fully managed service from AWS that helps developer to build generative AI application. In simple words, if I say whatever you saw in LM Studio, exactly what they are trying to replicate on AWS cloud, so that you don't need to manage all those like manual configuration and everything. And the same thing will be auto managed by Bedrock on their environment. You just need to select the model which you want to use. That's it. It allows you to train the model from scratch, fine tune both AWS in-house model, which is AWS Titan, and open source model like Mistral, Llama 5, or whatever. You have an option to import your own model. So let's say I trained a model on my computing instance on my data in a specific way, and I don't want to use Bedrock service for that because Bedrock is expensive if I fine tune or train a model there. I have an option to import my own weights on Bedrock, and I can host or inference it there. It automates the agent creation. You can use other services as well, like SageMaker, but that is more manual. You have to create the infrastructure behind it, and you have to manage it. That's going to cost you 24 cross 7 if you like host it all the time. But with Bedrock, it is serverless API. Whenever someone is going to make a request, then only it's going to charge you. Otherwise, they manage all the servers on their end. Whenever someone is requesting, they spin up the server and return the response. It is also used for logging and audit management. Using these models, passing the PHI or PI data to these models, you have to be very careful in terms of what request is going on into the model, because privacy is like a major concern. When you train these weights or models, it is very easy to reverse engineer some of the patterns. Let's say if the model is trained on patient data for a specific behavior, if somebody try, you can very easily reverse engineer that behavior. You may not get the actual identity of patient, but you can reverse engineer the behavior of patient. You can get the identification of patient also in case you use some PI information to train the model. Inside Bedrock, the way it works is it has two main components. One is action group and the second one is knowledge base. So the use case which I'm going to present is using RAG approach. So for that we need knowledge base. Action group is a collection of predefined tasks that agent is supposed to perform. So let's say I have my data stored at multiple places in database, in S3, and some other storage. So I need to define some predefined operations that whenever user is going to make a query, it is supposed to go to the database, fetch the information from there, and go to some other database, combine the information, and then prepare the context and send it to the model, or in between, if you have RAG, send that context or prompt to the RAG, do the similarity check, prepare the context, full context with examples, and then send that full prompt as a context to the model, and then generate the response. So this is what action group does. Second is knowledge base. Knowledge base is a repository where you can save both your structured and unstructured information in case you want to give some dynamic information, or you don't want to fine tune foundational model and want to use RAG approaches to prepare your application, you can simply use knowledge base and fetch the information. It is automatically going to fetch the information the way action groups are designed and work. Last one is CDK. CDK is a framework that allows developer to define cloud infrastructure as a code. So whatever services I have defined, you can go manually to AWS console, go to the service, and you have an option to create an agent manually. But if somebody asks you to replicate it, it's always very difficult. So instead of that, you can basically replicate everything in scripts, and you just have to deploy those scripts using CI/CD toolkits like Code Build or more, or CloudFormation, or instead of CI/CDK, you can use even Terraforms also. That will basically develop your code on the cloud platform. That's it. For the use case, I have prepared an example for automated discharge instruction agent. So this agent is supposed to prepare a discharge report for patients whenever they leave the hospital. Um, all the information specific to the patient is stored in my database. So I simply need to pass the patient ID, and their diagnostic behavior is stored in my knowledge base. So whenever I will make a request from an agent, that prompt will go to my agent group. Agent group is going to make an API call to my database to fetch the information specific to that patient. Then it's going to communicate with the knowledge base to fetch the dynamic information specific to the diagnostic. Will prepare that context in form of embeddings, and then we'll send it to the model of my choice. That can be a foundational model, or it can be some fine-tuned model specific to that behavior, and then ask the model to prepare the discharge summary report in this certain format. Architecture wise of this use case will look something like this. I'm going to have a base prompt template, which I'm going to send to the agent. Agent is going to save that particular prompt. So whatever response is returned by the model, I am also going to save that response with this tagged with this prompt, so that in future, if I have to check the performance of my fine-tuned or foundational model, I can go there and evaluate the performance. So this agent is going to make a call to action group. That can be your Docker ECS container, or it can be your Lambda, which is serverless application, or like whatever toolkits you or services you want to use there to communicate with your backend resources. We'll pass that information to knowledge base, gather everything, and then prepare the response. When it comes to installation of it, I told you that I am using CDK toolkit to basically wrap up all the manual tasks into a code, and automatically it's going to pick up that code. And when I will run this bash script, it is going to deploy it on my AWS cloud. For that, I need EC2 instance where all those dependencies should be installed. And I need to maintain those specific documentation specific to knowledge base or RAG use case in case I want to use. So those information will save on S3, which I am going to provide with the script itself. Some manual operations still I need to do. I mean, you can automate it if you want, but I have to sync my Bedrock agent knowledge base with the model, which I'm going to show you. Then I have to sync the data source, which is my structured or unstructured document that lives in knowledge base. I have to sync it with the S3. And once sync is done, I need to go to the agent and activate the agent. So I will quickly show you. So this is what AWS console will look like. You can search whatever services you want to go here. So I will show you quickly few things. So this is my EC2 instance where I will simply connect and get into the machine. So I already have prepared the code here. So I'm just showing it to you. the code is already deployed on the environment, so all the resources are already created. So this is my script where I have defined all the operations. If I go to the script, I'm creating all the stacks, like installing all the dependencies first, like Node or npm and all, then installing all the stacks which I need, like Docker or maybe ECR, like for creating that container ECR, generating bootstrapping innocent roles. This is for IAM, OpenSearch. This is for vector database APIs to communicate between database, Bedrock for Bedrock services. So this way I have wrapped up everything in here, and it automatically it's going to deploy everything on my instance. Um, so this is what we do everything from EC2 instance. Uh, for database, I will quickly show you. So this is my DynamoDB. If I go to the tables, you will see when I deployed the code, it automatically created a table in the database. And if you want to explore the table item, you can go there, and I have saved information for two patients. Let's say one ID of the patients and name and date of birth associated. But this is very basic use case. You can convert it into a very complex application in case you want. Next is your S3, where all the context will be saved when you install it. So these are all the resources which get created when we do the deployment of that specific code. Next is Bedrock. So this is where everything lives in. So I will show you like how it is similar to LM Studio. So in base model, all the open source model or closed source model, which are AWS models, are available here. And in the same way, you have to get access to these models from either AWS or maybe the model provider. Um, in case they have any restriction. Most of the time, there are restriction of accessing these weights directly. So you need to get approved from specific model provider. But all the general used models are available here in case you want to see. You have an option to create custom models. And the good thing about Bedrock is anyone can use it. You don't need to write a code for that. It will automatically, you need to provide the S3 path where your data lives. You need to pick the base model or foundational model on which you want to train, create a job to fine tune model. It will automatically going to do everything in the background or backend for you. You don't need to write a single script in case you want to, somebody does not have technical skills and want to train the models or fine tune the models. This is for custom weights which you trained on some other environments, but you want to import it on Bedrock. So we trained a diarization model to correct the diarization, which means at what time point which speaker is speaking in case you have multiple speaker in the audio. And you can host this model in the same way, but it's not going to be visible to everyone. This is hosted only in my account local infrastructure. For the use case, which I'm going to explain, is we need two items, which is knowledge base and agents. Once the deployment is done, I'm supposed to go to the knowledge base. I need to select the model of my choice. Let's say for we are picking up Anthropic Claude. And I need to sync my dynamic data, which lives on S3 with the model. So once this is done, again, the code that code which is provided by AWS orchestration branch is automatically going to create an agent for me. And I simply need to go there. If the status is unprepared, I simply need to click on it and prepare the status. So in this case, I will now. So these are like all the screenshots with specific things you need to do when you make a when you deploy it. So I'm asking the agent to prepare a discharge report for this patient with diagnostic acne, and utilize this template to prepare the final report. So whatever input I am passing to the model and whatever output is generated by the model, AWS is going to cost you based on the number of input tokens and the number of output tokens generated by the model. Okay, so it come up with the response. This is the patient name, and this is its date of birth, and prepare the report specifically to acne. With that, you also have an option to, again, I did not add any manual like any automated intervention in between that how or in what way it should generate it, but you have an option to automate the agents. It is also going to generate the traces for you that whatever role I am defining for human, whatever role I am defining human agent, and whatever role I am defining for my AI assistant, everything you can see here. And uh, you can also see the response, like what it is fetching and from where it is fetching before passing the final context to the model. In here you can see like more details in between, like what it is doing, the orchestration is doing with the knowledge base, how it's combining the information and then returning the response. I mean, I'm not expecting anyone to basically get into it because it costs you money hosting models on AWS, and it's very expensive. But I just want to give you a brief idea that how these real-time systems can be deployed and used on any cloud platform, and how it can be integrated with the healthcare system. Any questions? So we are done with the topics. So in case anyone have any questions, we can talk about it.
Yeah, I have one question also. How can we control output from LLM and maybe input? So how can we avoid such cases that LLM can propose some adverse output, some criminal, and so on? So just interesting, how can we control them?
Two ways to do it. Let's say you are building an API. So there are two things here: how you can control the output of the model and how you can control the input. So whenever you launch a model on Hugging Face, you are exposing your weights, and anyone can communicate with the model in any way. They can pass whatever input they want. So when it comes to privacy, people mostly focus on both input to the model and output generated by the model. So for input, one, if you are exposing your weights, you cannot control it. But if you are hosting those exposed weights on, let's say, Hugging Face, and you are allowing users to access the model from Hugging Face, in that way, you can add a layer where you can control the input. So if I'm asking to the model, give me the detail about patient X. So there are going to be pre-checks in pre-processing of generating the final context, which we are going to send to the model. You can add all those checks in there. This is one of the way to control the input. When it comes to the output of the model, again, you are going to have post-processing checks. The response generated by the model will go to that post-processing layer. You can have maybe some PHI checks or some other behavior checks in between, that if the model response is containing that specific information, it's not going to return that response and maybe send a generalized message. So if you use ChatGPT or Bard, and if you try to ask something specific, they simply give you a result that it's an AI assistant and it's out of its scope. So that way you can control the response in and out with those pre-processing and post-processing layers.
Okay, thank you.
I have simple question about the logic of this model, and have recently read the report of OpenAI about the structure and about the logic of model, and what's the main factor of logic of model due to language we use in model. For example, English and Ukrainian have the different logic and different grammar and different understanding, different sentence building, and what is crucial fact of building this model due to language here. Thank you.
There are multiple factors which comes in picture. All these things were already available before these large language models were like introduced. So whatever language you pass to the model, you basically convert the context of that language into vector space. So doesn't matter it's English or Ukrainian or any other language, those vector context for language meaning is going to same. So this is the way recently these multilingual models are trained and very efficiently on very small amount of data. So that context of each language in that vector space you cannot change. And that way, like this is like the base layer or main logic, or I will say pre-processing logic involved when you fine tune any specific model and feed it into your larger models to modify the weights. Isaac, do you want to add anything in here?
No, I thought that was a great answer.
Cool.
Okay, thank you.
I have a question, quite technical one. Is it possible to launch large language model, some large language model within the LM Studio, such that it would provide API compatible with OpenAI standard? So we could deploy this large language model locally and call it from our local applications.
Yes, that's what LM Studio does actually. Whenever you select single model or multiple model, you have an option to launch X number of model from your local machine if your configuration is strong enough. So that localhost URL which I shared, within your local machine, you can access it wherever you want within your local machine. But when it comes to launching these models for general use case for like more people, then you either need a cloud service or some platform where you can host it.
So where can I find the URL of the endpoint when
Okay, I will show it to you. So when I started the server, it gives you the demo examples. So in here, it will automatically generate the base URL for you. And this is what you have to use. This is where this 5.3 model is hosted.
And there will be no APK. I see APK.
No. API key is going to be blank because there is no API key required to access the model in your local machine. And once you are done with it, simply stop the server.
I see. Thank you.
Hello. Yeah. Thanks for your presentation, by the way. I have a small question. Is it possible to use, for example, SharePoint as external resource to index document inside SharePoint to help the bot to create an answer. For example, if I want to create a bot for some specific field, and I have a lot of documentation with additional information, can the bot with your resources that you show, it was AWS Bedrock and AutoGen, is it possible to connect some SharePoint, for example, or other document store to index some documentation? And if yes, did you compare it with RUR ML services? Because RUR ML services is a bit a lot of cost to do the same stuff. And maybe you faced with this issue and maybe already solve it.
I mean, I did not try, but if I read the online content, then yes, definitely you can integrate it with any kind of data resources or storages you have. The only thing which you have to do is your agent domain or agent group is supposed to make an API call to SharePoint and will access the data from there and will provide it to the knowledge base in AWS infrastructure. And that way it will save those embeddings in the open search. So it's all kind of API game where you can connect your context with whatever kind of data resources you want. So there is no limit to that. It can be in any form, structural, unstructural, or it can be anywhere. As long as you have access to it, maybe with via API or API keys, you can connect it with any kind of resource.
Yeah, thank you.
And even you can do it cross cloud as well. I mean, you can connect resource within AWS from GCP or Azure as well. So there is no blockage there.
Yeah, got you. Okay, thank you so a lot.
Okay, I guess that's all the questions that we had. Thank you a lot. It was a great lecture, and we really appreciate if you could send to Alexei email your presentation, because it was really, really valuable for us. Thank you.
Yeah, definitely. And good luck with your summer program. And I guess we all are connected on the group. So in case anyone is having any questions, I'm always available there. And Al, if you want to add anything.
No, yeah. So it sounds like we're all connected on the Telegram group, and we're happy to help out. VJ and I will collaborate with the group around the LLM work. And yeah, this is a lot of fun. Thanks everyone for attending and inviting us.
Thank you.